In this example, we're going to look at another problem involving leaning rod. We're told that the rod is uniform and has a mass of 4 kilograms. Therefore, because it's uniform, the weight will act down the center. So we'll have the weight as mass times gravity. And again, we'd want to resolve this. And the angle here will be the same as the angle right here. So that will be 20 degrees. The end is resting on rough horizontal ground, and as per usual, rough indicates the presence of friction, so we'll have friction here. And we're told that the other end is attached to a fix. The other end, B, is attached to a light string, so we will have tension acting along the string. So we will resolve this, so we'll have a vertical component and then a horizontal component. So here we can show that this bit here will also be 20 degrees. This bit will be 70 degrees. And you can convince yourself of the same. So the other force will be at point A, you'll have a reaction, a normal contact force or a reaction. We'll label it RA. And so the rod is in equilibrium. We're not told that it is in limiting equilibrium, so we'll leave it as friction for the time being FR. Later on, they're going to tell us that the rod is about to slip, but for the time being, we'll leave this bit as FR. All right, so they want us to work out the tension that is in the string. So as per usual, you have 4 steps that you must work through. You must do a detailed force diagram, that is step 1. Step 2, you must resolve vertically. And this is standard notation for Edexcel. So if you write it just as I've written it on your exam, this will be acceptable. So resolving vertically, all of the up forces added to all of the down forces. So the up force, because we're in equilibrium. So the up force is RA. The other up force is this. That will resolve to T cos 20. So that's T cos 20. And you can convince yourself by SOHCAHTOA that that is indeed true. And that will sum to all of the down forces, which will be 4G. So that will be equation 1. Or we can call that equation 1. Next, we're going to resolve horizontally. That means the force is acting to the right, which is FR, will be equal to the force acting to the left, which in this case will be T sine 20. So we can call that equation 2. So this is T cos 20, this is T sine 20. Next, we are going to take moments about the point where the rod hits the ground, and that point is point A. So by definition of moments, we know that we're dealing with the perpendicular distance away from the pivot point A, multiplying by the distance away from the pivot point A multiplied by the perpendicular component of the force at the halfway mark. Here, so it will be 0.7 times the force that is perpendicular to the rod, which is going to be 4G cos 20. So 4G cos 20 degrees. So that will be the clockwise turning effect, which will perfectly match, since we're in equilibrium, the anti-clockwise turning effect. So that will be the anti-clockwise turning effect will be the distance times perpendicular component of the force, which is T. So that will be 1.4 T. That's equation 3. From equation 3, we can see it's fairly straightforward to work out tension. So tension will be 0.7 times 4 times 9.8 times cos 20 divided by 1.4. And again, you can check with the exam board which value of G to use. So generally for Edexcel, it will be 9.8. So 0.7 times 4 times 9.8 times cos 20. And then we divide that by 1.4. So T will be equal to 18.4 to 3 significant figures. But because G is the 2 significant figures, ideally we want to rewrite that T as 18. So 18 newtons to 2 significant figures. So here now they tell us that the rod is about to slip. So we can now rewrite this and say friction is going to be mu times Ra. So we want to use the value of tension that we have worked out to work out Ra. So Ra will be equal to 4G minus T cos 20. And so Ra is equal to 4G minus T, which is going to be 18.4. We'll use a calculator value and then times by cos 20. And so 4 times 9.8 minus the calculator value for T, and then times that by cos 20. So that means that Ra is equal to 21.9 to 3 significant figures. And if we now use equation 2, so from equation 2, we know that friction is equal to T sine 20. So T sine 20 is going to be less than or equal to mu times Ra. Well, in this case, because it's about to slip, it will be strictly equal to mu times Ra. So therefore, mu is equal to T sine 20 over Ra. So we sub in the values. We know that T is about 18.4, and then we times that by sine 20, and then we divide that by Ra, which is approximately 21.9. So if we type all of that in, so 18.4 times by sine 20, and then divide by, and then we're going to get mu is approximately 0.287. So normally I would record mu to 2 or 3 significant figures. I would use record mu in exact form. So mu is approximately 0.29. And the reason why I wouldn't write mu in exact form is because the calculation of mu involves G, and G is written to 2 significant figures. So sometimes the examiner will give an exact value for mu, but I think that is an error. I think that mu should be written to 2 or 3 significant figures.